The schema for this app is pretty simple. I've got an object called contest, and then there is another object that you create off of that that's a master detail called prize, and you can specify the quantity and value and stuff like that of the prize. And then there's another object called entry. And so the contest will have some prizes that you set up in advance, and then as the entries start piling up, those are also master details of the contest. And then there's actually a lookup from entry to prize. And this really only applies to the winners. But whenever somebody wins a certain prize, then that entry will now be linked to the prize that they won. And then if you look at the prize, you can see those entries, and they're listed as a related list called winners. The schema for this app is pretty simple. I've got an object called contest, and then there is another object that you create off of that that's a master detail called prize. And you can specify the quantity and value and stuff like that of the prize. And then there's another object called entry. And so the contest will have some prizes that you set up in advance, and then as the entries start piling up, those are also master details of the contest. And then there's actually a lookup from entry to prize. And this really only applies to the winners. But whenever somebody wins a certain prize, then that entry will now be linked to the prize that they won. And then if you look at the prize, you can see those entries, and they're listed as a related list called winners. The entry has also got a bunch of lookups on here that you can't see, so it could be connected to contacts and leads and users. That lets you relate things in Salesforce if you want to use it for CRM type purposes. Now, every entry has a sequence number, and this sequence number is meant to help us get around some of the governor limits we have. This class is called Drawings Data Prep, and in most situations, as the results come in, there's an invocable method that gets called from Process Builder. It passes in the contest ID of all of the records that are getting created. And so those entries, they may all be for the same contest. And in that case, we only want to run this process for that one contest ID. If they were a mixed bag, you do something that puts entries in a couple of different contests, then we might be running it for several IDs. And in all these situations, we're just going to call this incubable apex method. And what it's going to do is call this method called number stuff. So we're going to look for any records that don't have a sequence number already. We're going to get the biggest sequence number that we had, and then starting from there, we're going to apply new sequence numbers to anyone that didn't have one already. And then it returns the number of records that it didn't get to. And so in most cases, I'm trying to imagine a situation where this is not 0. But just in case it's not 0, then we'll kick off this job again to do another run to go get back more sequence numbers. So this is called from a process builder. Once it gets installed, you could turn that job off and then maybe just let all of the entries pile up with no sequence number, and then maybe you sequence them when it's time to do your drawing at the end rather than as you go. Each of those action buttons that you saw are Lightning component actions, so they implement force Lightning quick action without header. And they also have record ID, so they can pass in the ID of the prize, or in the case of the draw everything for the contest button, the ID of that contest. They're pretty simple. They call an init method, which is going to reach back onto the drawings controller. So this one for draw single prize is going to just pass in the prize ID. And then it's going to get back the names of the winners. And so it just does this nice little green toast thing to show you the name of the winner. There's 2 other standard events that it calls. So one is to refresh the view, because by default, that related list of the winners needs to get updated. And so by calling refresh view, it reloads the record details and the related list. And then we close that quick action. So it's opening up a little modal dialog, and you'll see it flash on the screen for just a second while it's thinking. And then once it gets the winner and shows the toast, it will close that. There's also some standard code in here that I use in all my components. If you haven't seen this, it's part of the Lightning base package. There's a component called error handler, and there's an event that you throw it. And so I just pass in the error from any callbacks that I get. And error handler doesn't have any markup, but it will iterate through all the errors, because there could be page errors, there could be, if you set up duplicate rules, there could be duplicate, it could be validation rules. All right, so let's look at this draw single prize method on our drawings class. There's a few of these here. So here's draw single prize. You pass in the prize ID. And there's some logic just to make sure that we maintain the integrity of the contest. So one, we want to make sure that there actually are prizes left. So there's a query down at the bottom that says, for this contest, for this prize, are there any prizes left? And then if that number is not there, we're going to throw an error. And that's going to show up in that error handler that you just saw, so you'll get a nice red toast message about this. The other thing we want to do is to get the sequence numbers of any winners that we've already drawn. And so for this contest, if an entry is already won, then we don't want to let it be the winner of two different prizes because that prize will get overwritten. And so that gives us our existing winners number. And then what we want to do is pick an entry. We're looking for an entry for that contest, for that prize, obviously. Have a system here that randomly draws a sequence number. And we want to make sure that they didn't already win a prize. And so this get winner key gets used a few different times. So let's go down and look in that. So what I want to do is pass in the number of entries on this, because obviously we will want to generate a random number between 1 and the total number of entries inclusive. And then we also need the set of existing winners. And so, for example, if sequence number 5 and 256 have already won a prize, we want to make sure that it's not one of those. And so what we're doing is we're doing a random draw with this random number. And then what I've done, because if this will generate something between 0, and so I want to bump it up by a half point so that the stuff will either round down to 1 as our lowest number. Nothing should round down to 0. And then could be as high as the very highest number. A little extra fairness for the very first and very last person to enter the contest. And then I've got a do while loop here. This is always a scary thing to do. But what I want to make sure is that our number that we think might be a good winner key isn't in our existing winners, and that it's not 0, and that it also needs to be less than the entry count. And then we will return that number. And so back in our single drawing, we get this list of winners, which should be exactly 1 because we're only drawing 1 prize. So whoever had the sequence number that matched our winning key. So I give them the prize, and this populates that lookup. And then there's a flag on the prize object that marks it awarded, which means we've given out all of these prizes that we have. And so if there happened to be 1 prize left, up earlier, before we awarded this last one, well, then now there should be 0, so we're going to mark that one there, and then just do an update. The other actions work the same way, so I'm not going to show them to you. So there's a draw all action, and it's exactly the same on the UI, except it's going to call this method. And this is all for drawing all for the contest. And then there's also one that draws just this prize. Let's look at this one first. So this one is going to draw all of the winners for a prize. And so what we have to do here is similar to what we did before, but this time we're going to build up a set of winner keys. And so because of governor limits, what we can't do is query the entire batch of entries because it might be more than 50,000. And so what we want to do is build up a set of winner keys. And we're going to take the existing winners and obviously put them in the winner keys. And then we're going to keep drawing winner keys, including our existing winners. And it's going to be, this is a set. So what's nice is if we draw number 5 and we add it to our set, and then later we draw number 5 again, that number 5 is already in our set, and we're just going to have to keep drawing until we get the set big enough. Because this is a set, it's got built-in deduplication. So then it's easy to do our query. We just need to find winners who are in that set of winner keys. Then we give them all that prize. And because we're drawing all of the remaining winners for this prize, we can mark it as awarded. And what we're returning as a list of output is actually a list of all the names. And so you see that pop up is just a comma-separated list of the winners. The most interesting one we have so far is the draw all method. And so here we need to look across all of our prizes because we need to find that many winners based on how many quantity, right? So if one is 10 and one is 3 and one is 1, then we would need 14 prizes. So we've got this integer for total prize count. And then we've got our existing winners. So if we had any of these that have already been awarded, we're actually going to throw an error. We can't do a full draw if any of those prizes have already been awarded at all. We need to make sure there are some sequence numbers. We also need to make sure that there are enough entries for the prizes that we're about to try to give out. So if you have 14 prizes and only 10 people entered your contest, that would also be a problem. So similar to what you saw before, we're going to build up the winner keys. And I've got some checks here just to make sure that no matter what's happening, in the case of bad sequence numbers, like someone goes in and deletes 15 of the entries for some reason, we do need to make sure that we have a solid number here. And so then I just go in and grab my winner keys. What I have is I have a list of winners, but I haven't necessarily determined which prize they won. And so here I need to figure out which prize I'm going to assign to each of these folks. So I've actually got another list here where I'm going to build, for every prize that needs to be given out, a list of the prize keys. And then I've got a function below that does a random sort. And so I have my list of winners, and then I have a randomized order of prizes, and then I just go through and match them. And along the way, there's a lot of assert statements just to make sure that the logic here is making sense and that there's the right number of each things. As we look at how the dramatic drawings work, I'm going to start with the Apex class on the server, and I'm going to do this slightly out of order. What I'm going to show you is the order in which it got built. The simplest possibility is that we have less than 1,000 people in our contest, and so those entries, we're just going to pull all of them. And because we want to use the photo URLs, we have two different options here. There's winners with pictures, and in that case, we really want someone who is a user, and that's why they have a chatter photo. And their chatter photo could just be the standard one, but we're going to pull it. And interestingly, there's actually two options. There's a medium and a small. And so most people have a medium if they've updated it very recently, and it's going to be a higher resolution image and it'll look a little bit better. And then you have the other scenarios where it's not a user. And so in that case, I don't have a picture for them. And so I don't want to query those fields because these relationship fields will throw an error if the user object doesn't exist. Then I just merge those two lists and I will return that as a serialized list. So that was what I built first. It was really simple. And then I needed to scale it for situations where I had way more than 1,000 entries in my contest. And so this was what was built second. After we check the prizes and how many are left like we did before. If I've got more than 1,000 entries, I'm just going to start generating random numbers until I have 1,000 of them. And I build up a set of winner keys like we did before. This time, instead of a few of them, based on how many prizes you're giving away, this time there'll be 1,000 of them. Because they're not really winners, they're sort of contestants for the graphical dramatic drawing. And like you saw earlier, we have both scenarios, with or without pictures, and we merge those lists. So this was a fairly simple operation, but it turns out that I missed an important scenario. I'm going to keep drawing random numbers until I have 1,000 entries. The problem happens if you have something like 1,010 entries, and you have to keep drawing random numbers, hoping to get 1,000 out of the 1,010 possible entries. There's a pretty good chance that one's going to time out. So there's two branches here. If the entry count is more than twice the number of entries that you need, then we're going to do this additive method in which we start with no winners and we keep drawing random numbers until we get enough. There's the other scenario where it's less than 2x. And so in that case, it's easier to take all the existing winners and use our random number generator to remove numbers and then query for all the people who are not in that list. So instead of winner keys, now we have loser keys. Everything else is the same, but this makes sure that we don't spend a whole bunch of time drawing random numbers repeatedly trying to find the ones that we haven't used yet. All right, here's what happens when you click that dramatic drawings button. This is the actual button component, so that custom action that is a Lightning component. It has a controller, and it's going to navigate you to our dramatic drawings component. And that has one important parameter, which is the record ID of the prize that you're awarding. Here's that component itself. I'm using two common libraries, D3, which is all the fancy graphical stuff with the bubbles and everything, and then Lodash. This is the duration in seconds that I want the animation to last. And then here's some of my local variables. This handler listens for URL changes so that this component doesn't stay running in the background if you navigate away from it. Error handler that you saw earlier. And then I've got one class here, And it's mostly just going to be replaced by the D3 animation, but there's a couple things I wanted here. I wanted to have the prize name listed on there. This also gets a background image. And then once I've awarded the prize, I want this lightning button to show up so that you can navigate back to the prize without having to use the back button. I need to do some basic geometry measurement, and I'm going to figure out how big that div is that I'm working with. So I need to know its height and width, and that'll let me calculate its center. And it'll also let me calculate the aspect ratio because I do want these bubbles to fill up this whole space that's available. I've got a constant here for how many animations per second I would like to have happen. And then there's two other constants for the gravity to charge ratio. Gravity is going to pull everything towards the center. And if that number is too high, then all the bubbles just collapse on each other. And then force strength is the aggressiveness of the animation. And so if this number is turned up too high, the bubbles get really, really busy trying to find the perfect spot. Here I create the D3 canvas that I'm going to do all the drawings on and stick an SPG element of my dynamic height and width into the pre-selected div on the component. Here's a bunch of variables that I'm going to use later that I do want at the very top level of this function so that they're not scoped out of any other closures. This helper function is pretty simple. It calls Apex and gets the name and the image for this prize and loads them in the appropriate place. I'll show you that real quick. It makes a call, and then the only thing that's really fancy here, I guess, is I'm going to use D3 to set the background image URL of that div on the page. Now we're going to call and get those 1,000 entries, or how many ever come back based on the size of the drawing, all the fancy logic that we just looked at. I pass a prize ID, and I get back a whole bunch of results. Because that's a serialized JSON string, we will parse it. And then I'm going to use one of those things that you learn in Algebra 2 that you always swear to your teacher that you're never going to use in real life. This is how to do an exponential decay function. So based on the number of results that came back and how many ticks per second I want and how long I expect this animation to last, I need a decay rate. We'll check how many results we originally had. And there's this variable called global radius. You'll see it used throughout the entire code. All the bubbles are always the same radius as each other, but they grow over time as the results come down. And so if there are lots and lots of results, I need very small bubbles. And if there were not very many results, I might want larger bubbles. And so this radius evolves over time. And then finally, I've got a lot of the node construction stuff moved over into a helper, but I just need to pass in the radius and the height and the width. It's going to create those nodes for me. And I'll show you what that looks like. So here's node builder. It gets these variables, and it's really just building an array of these JavaScript objects. Set the radius, I set the name. The initial locations of these things, I randomize, and we're just going to throw them all on the screen, and we'll let gravity and the charge forces that adjust how the bubbles are laid out deal with it after that. I do need their Salesforce ID so I can update the winner at the end. And the image, the logic for that is actually in another little helper method here, because it might have a user, and if it does have a user, it might have a medium, and that's my preference, but if it doesn't have a medium, then I'll use the small. So now I've got my data, and I'm going to be working with three primary D3 objects. One is the bubble, which represents circles, and so if you see an entry that doesn't have an image, it'll just be represented by a gray bubble. There's the image itself, and here I get the image off of the result and set that as the URL link. And we've also got the label, which is the name of the person on the entry. And then we're ready to start the simulation. So I call D3 force simulation. I pass in my nodes. These are all the data array that we built. I set the alpha decay to 0 because I don't want the bubbles to slow down. I want them to keep moving. And I've got two forces, one vertical and one horizontal. And what's important is that they're not the same number. In most situations, X will be smaller than Y because we're dealing with a landscape orientation monitor, and I want to fill up that space. And this tick event is an animation on the simulation. So every time a tick unit of time happens, we're going to call this method ticked. All right, here's the ticked method. For the bubble, I will move the vertical and horizontal center of that bubble. We also need to update the radius because as the global radius grows, the bubbles need to grow. The labels will be moved the same way. They'll be moved vertically and horizontally. And as the radius grows, we're going to increase the font size on them. And same thing with the image. The image doesn't have a radius, it has a height and width. And so we'll use the radius to calculate the height and width. And then finally, I'm going from square images to circles. And so I've got a clip path CSS property that happens here. And as the radius grows, we need to grow the clip path, which graphically defines all the things that we want to not show. So at this point, we would have a running simulation with a whole bunch of bubbles on the screen, images if they have them, and they would all be moving around slightly, trying to find gravity and repelling each other. But because this is a drawing, we need to get rid of some of these bubbles. So there's a function here called reducer. It's going to run on a JavaScript set interval. And if you've never done one of those in Lightning, this part is really important. Use the $a.getCallback. And then everything inside here is going to start removing those entries. I've got a check here to make sure that we still have more than one entry. There's also a safety valve that we're going to increment on every run of this because we shouldn't run it more than 1,200 times. This line here is kind of interesting. I'm going to calculate what the amount of remaining nodes should be at this point in our decay. And if we already have that many nodes, that means we're not going to take any out. We can simply increment our interval counter and move ahead to the next tick. But most of the time, especially early on in the animation, we're going to want to remove nodes. So I've got a function here to deal with node removal. We'll go down and look at that real quick and then come back to the rest of this process. So on remove node, we do our increment. And then I'm going to use that same decay function to figure out how many nodes we should have at this point. Here's why Lodash is used. It's a really easy way to say, of all of the input that I have right now, here's how many that I want left. So you might come in with 100, and then at this point, your decay function says you should have 80. So it's really easy to ask Lodash to give you 80 random nodes from your sample of 100. And then we do a radius update because now we know how many nodes we have, and then we return those nodes to the reducer. At this point, we're almost going to do the D3 animation that we did earlier on our three functions, label, bubble, and image, but we need to remove the existing label, bubble, or image, and then set them again. So our labels and our bubbles and our images all have a remove function, and then we go back in them and update them with those new points and new radius. Once that's done, we call simulation and let it know that we've updated the nodes. Because this is running on a set interval, it's going to keep running in loops. So if we've already got a winner, or we've already saved the winner, we don't want to keep running the loop. And then there's that magic moment when you're down to one winner. So you call simulation.stop, and that stops all the fun D3 animation. There's an action here to update that winner. So it makes an Apex call, passes in the prize ID, and then the winner's Salesforce ID off of the entry. And then we call the winner, give the toast message, marked it as saved, and we mark it as awarded, and then we stop the loop. The loop may run a few times while the Apex transaction is out. After we send the Apex, while we're waiting on it to come back, we do move it into a pending stage so all the animation can stop. This is the navigation function that can take you back to the prize after you've done your drawing. It is fired by that button that appears on the page. And then finally, here's that function for the component destroyer. So when that event happens that says the location is changed, call destroy component. This is destroy component, and it makes sure that we're not still running all of this heavy animation stuff while you're on a different page in Lightning Experience.